Hello again. The sharkC64 language has now 4 loops. Let's have a look. Let's open the newest example. This program fills the entire screen with a character. It goes through all the character values from 0 to 255. In the program, the fill screen function has 2 nested for loops that do the actual filling of the screen. The outer loop traverses all the rows on the screen, and the inner loop traverses all the columns on the current row. The module body has also a loop statement. It calls the fill screen function with all the possible character values. Let's run the program to see how it works. The sharkC64 language supports also descending loops. Let's change the loop to a descending loop that calls the fill screen in reversed order. Let's run the program again to see the effect. Let's have a look at the loop in the module body. The parser and the binder were extended to recognize and support for loops. After parsing and binding, the for loop is translated to the intermediate representation language as follows. To support faster execution of for loops, the intermediate representation language was extended with increment and decrement instructions. In the translation, the loop variable is first initialized with the starting value. Then the loop variable is decremented by 1. This may seem surprising, but it's a technique to allow a simplified translation of the loop body. In particular, it allows us to use a translation that starts by incrementing the loop variable by 1. In this way, the comparison for the final value is simplified, and it also ensures that all the values are traversed, including the final value in the loop. As for the bytecode generation, this is what the loop example looks like in the assembler language. So that is what the for loops look like in the sharkC64 language. As for the next step, I will add support for function parameters. Until then, thanks for stopping by and see you soon!